In this video, we're going to see why the range of arc sine is between negative pi over 2 and positive pi over 2, including those n values. So we're also going to see why the inverse sine function could also be called arc sine, literally because it has an arc in it. So we're going to look at the graph of the sine function, and there's approximately 2 periods shown here. And if you remember from Algebra 2, this is not a one-to-one function, because although this function is a function, it passes the vertical line test on all of the domain. The problem is the horizontal line test that does not pass because it intersects the graph clearly at more than one places. And the horizontal line test tests whether or not the inverse is a function. And the important thing is, why does a function need to be one-to-one? Because when it comes to evaluating the inverse trig function, it needs to be a one-to-one function. So the answer for why it's not one-to-one is because it does not pass the horizontal line test. I'll abbreviate here. So a horizontal line test is it has to pass both the vertical line test and the horizontal line test. In other words, both the inverse and the original function have to be a function. So it's not one-to-one, but can we restrict the domain in order to make the sine function one-to-one? And that's where the arc is going to come in handy. So it turns out that technically between the x values of negative 3 pi over 2 and negative pi over 2, this little arc here, if we did the horizontal and the vertical line test, that works. But the thing is, in math, we love to center things around the origin, and we also like positive numbers. But in this case, right, so the similar thing is here between positive pi over 2 and positive 3 pi over 2, that arc is also one-to-one. But what we're really interested in, again, we like to center everything around the origin because it just makes everything easier to work with. So this is where we first start to see that if we restrict the domain, in other words, we look at the x values between negative pi over 2 and positive pi over 2, that's where that comes from. So the domain we're going to restrict in the original function is obviously we can include the n values, right? Negative pi over 2 and positive pi over 2. Okay, so we have now made this function one-to-one, and actually I'll just leave this highlighted here. So what we're going to do is we're going to graph the inverse. So the next set of question is, what is the domain and range of that piece or that arc of the original function with that restricted domain? So we just talked about, I'll put D for domain here, is between negative pi over 2 and positive pi over 2. And if we look at the range, or we're going to look at the set of y values here, right, we're going to see that it's between negative 1 and positive 1. And so if we remember from Algebra 2 class, when you compare an original function f and its inverse, it turns out that the domain and range flip. So in other words, you can actually, if I go up to the original function, if we wanted to graph the inverse, if you remember from Algebra 2, we're going to take all of the x and y values in an ordered pair, and we're going to flip it, or we're going to switch. So in other words, that point negative pi over 2, negative 1, the x and y values flip. So now we're going to be graphing negative 1, negative pi over 2. 0, 0, right? If we flip the x and y, it's going to stay 0, 0. And then this last endpoint here of the arc, if we switch the x and y values, it's going to be 1 and then pi over 2. So the inverse function looks like this, right? So the negative 1, negative pi over 2, 0, 0, and then 1 pi over 2. So if you have not seen the inverse graph, it looks like this. And so just a reminder, the inverse sign can be written as sine to that -1. And then it can also be seen as arc sine, and that is where that arc comes from. So whenever you see arc sine or arc cosine or arc tangent, so on and so forth, it just means inverse. Okay, and again, because of that arc. So using this graph here, what is the value of inverse sine of -1? And again, I could also be writing it as arc sine of -1, right? So it's saying the same thing. So this is, we're going to input -1 into the function, right? So if f of x was inverse sine of x, so we're looking for f of -1, right? Because if I substitute -1 into the x spot, right, this is what we're trying to look for. And so if you remember from Algebra 2, this is asking what is the y value when you input -1 as your x value. In other words, when we look at the ordered pair, right, when you look at x is -1, what is the y value? And we can clearly see, if you look over here, the answer is going to be -pi/2. So -pi/2 would be our answer. And so if you look on the unit circle, if you were asked this question, what's inverse sine of -1? We're going to see later. So in the -pi/2, it's coterminal, or it's in the same spot as 3pi/2. And a lot of people would make this common mistake, and they would put 3pi/2 as their answer. But the issue is it's not in the restricted range. And that is why your teacher is going to take off points. If you put 3pi/2, you do get half credit just for having that understanding. But again, that correct answer would be -pi/2. And we're going to talk about, you're just going to subtract by 2 pi radians, right? That's how you find that coterminal angle. Okay, so if we look at, we just finished talking about that the restricted range is from -pi/2 and +pi/2, right? So actually, that's one thing I missed when I go up here. I forgot to actually answer this question. So find the domain and range, right? So D stands for domain. So now the x values are between -1 and +1. And the range is going to be the x values. So that's between -pi/2 and +pi/2. So this is where the range comes from. Okay, so whenever you do an arc sine problem, your answer better be between -pi/2 and +pi/2. And if you pay attention to the original function, notice that the domain and range flip, right? In the original function, the domain was -pi/2, +pi/2, right? And this was our range. And now we flipped it. Okay, so the restricted outputs or the range, so your answer is going to be -pi/2 to +pi/2. So if we look at the unit circle, so your answers, when you're going to evaluate, it's going to be between quadrant 1 and quadrant 4, right? So here's +pi/2, and 3pi/2 is coterminal, so I can actually also put this next to it, right? -pi/2 is the same thing. So our answer is going to be between quadrants 1 and 4. So for example, if you are asked the question to find inverse sine of square root of 2/2, so how you do this is, remember that the x coordinate would be the cosine and the y coordinate would be sine, right? So we're going to be looking at the y coordinates of the unit circle. And then later when we do the tangent, obviously we're going to be doing y divided by x. But in this particular example, we're going to be looking at the y values. So where do you see a y value as positive square root of 2 over 2? We're looking over here in quadrant 1. But if you ask yourself, wait a minute, positive square root of 2 over 2 is also over here at 3 pi over 4, but we know that that's going to be incorrect because we just finished talking about your answer better be between quadrants 1 and 4. So 3 pi over 4 would not be correct. So the correct answer would be pi over 4, right? Because it's in quadrant 1. And so that would be a quadrant 1 solution. Let's take a look at what if we had a quadrant 4 solution. And so when you do this, there's going to be an extra step because you're going to have to find the coterminal angle. Okay, so we're going to try an example. Here is a quadrant 4 solution. So what if you're asked where the inverse or arc sine is negative square root of 2 over 2? So in other words, we're going to look at where the y value, because we're dealing with sines here, where is it negative square root of 2 over 2? Technically, we can look here at 5 pi over 4, and we can look over here at 7 pi over 4. And so again, we are looking for answers in either quadrants 1 and 4. So we can't look at over here at 5 pi over 4 radians. And then a lot of people would write the answer as 7 pi over 4. You would get half credit. That is not correct because 7 pi over 4 is not between negative pi over 2 and positive pi over 2, right? So again, if people did this, 7 pi over 4, that is not correct. So how do we find a coterminal angle that is between negative pi over 2 and positive pi over 2? So the rule of thumb is if a solution falls in quadrant 4, that extra step is you have to subtract by 2 pi radians. In other words, we're going to find a coterminal angle, right? So what you're going to do with that 7 pi over 4 is, I'm going to do this up here. And maybe let's do some green here. So we're going to take 7 pi over 4, and we're going to find a coterminal angle. So we can add or subtract 2 pi, but we're going to subtract 2 pi, and we're going to use our amazing Algebra 1 skills. We need to find common denominators, right? So 2 pi is really over 1, and we can multiply the top and bottom by 4, right? So 2 pi times 4 is 8 pi, and then 1 times 4 is 4, right? So 8 pi over 4 is the same thing as 2 pi. So now we have common denominators, so they're going to share 4 as the denominator, and 7 pi minus 8 pi is going to be negative pi, right? So the correct answer is negative pi over 4. That is inside the interval. So again, just in a nutshell, whenever you have a quadrant 4 solution, you're always going to be subtracting by 2 pi radians to ensure that your answer is going to be in the correct interval. Okay, so let's do 3 problems. Okay, so what if you're asked arc sine of 1/2? Okay, so again, we're going to look in here, okay, and we're doing sine problems, so we're looking at the y coordinates. So where is it positive 1/2? We're looking over here, so our correct answer is pi over 6, right? So when you have a quadrant 1 answer, it's always going to be in that correct range. You don't have to do anything, right? So the extra step is when we have quadrant 4 angle, right? So number 2, arc sine of negative 1/2, and our y value is going to be down here. So we're looking at the 11 pi over 6 spot, but that's not the correct answer. That's not in the range. So we talked about you're going to be subtracting by 2 pi radians so we can find the coterminal angle. This is over 1, and we can multiply top and bottom by 6. And so that's 11 pi over 6 minus 12 pi over 6. And so the correct answer is going to be negative pi over 6. And last but not least, for number 3, we're going to do inverse sine of positive 1. So that's actually only one spot, right? Here's where the y value is positive 1. So our correct answer is pi over 2. So deriving the range of arc cosine is going to be similar to that of arc sine. So here's about 2 periods of the cosine function, and it's not 1-to-1 for the same reason that the arc sine is not 1-to-1. This does not pass the horizontal line test. Okay, because if we draw a horizontal line, we can see clearly that it hits the graph in more than one place. So the relation is a function, but not the inverse. And again, we need the function to be 1-to-1 in order to evaluate. So again, we're going to have to restrict the domain of the original in order to make it 1-to-1. So we're going to do look for something that passes both the vertical and the horizontal line test. And technically, from the x values or the domain of -2 pi and -pi, that of course works. But again, in math, we like to center everything as close to the origin as possible, as well as we like positive numbers because they're easier to work with. So again, technically from -pi to 0, that passes both tests, but those are in the negative world. So it looks like our golden ticket here is going to be between 0 and pi. And that is the reason why your answers when you do arc sine problems better be between 0 and pi. So if we look at the domain here, so the domain and range of the piece of the function with the restricted domain, so we could see the domain we talked about was between 0 and pi, and the range is going to be, again, if we look at the picture, it's going to be between -1 and +1, just like the sine function here. Okay, so when we graph the arc cosine function, remember the domain and range, we're going to see that's flipped. And also we're going to look at the cosine arc, switch around the x and y values of each coordinate, and then graph. So it should end up looking like this. Okay, so again, in order to graph, 0, 1 now becomes 1, 0. Pi over 2, 0 becomes 0 pi over 2, and pi -1 becomes -1 pi. So if you graph those following coordinates, -1 pi, 0 pi over 2, and 1, 0. So here's the graph of arc cosine, or y equals cosine to the -1, so that means arc cosine, and again, you could see it like this, arc cosine of x. So if we look at the domain and range here, we're going to see that it is flipped, and in fact it is, because if we look at the x and y, excuse me, the x values, it's between -1 and +1. That was actually the range of the regular function. And then the range now is 0, between 0 and pi. And this was actually the domain of the original function. So whenever you plug in values inside the arc cosine function, again, your answer better be between 0 and pi. So let's take a look on the unit circle. Actually, I take that back. Before we do that, so what if you were asked to find inverse cosine of 1 or arc cosine of 1? So again, if the function f of x is inverse cosine, we want to find f of 1, right? So if we plug in the number 1 for the x value, so we're trying to find f of 1, right? And this is exactly what we're trying to find. So again, from Algebra 2 class, you know that when you input 1 as the x value, so what is this asking for? It's asking for the y value of that ordered pair. And again, if we take a look over here, we can see that this ordered pair is 1, 0. So the correct answer would be 0. Okay, so If we look on the unit circle, so now cosine, right, we always look for the x value of the ordered pair on the unit circle, right? So we were doing arc cosine of +1. So since we're in the cosine world, we're looking for the x values. So where in the unit circle do you see the x value +1? We can clearly see that our answer is 0. So that does check out. Now, because the domain is, or excuse me, the range or the outputs is from 0 to pi, we can clearly see that, let me erase this here. Here's 0 and here's pi, right? Technically, just to be on the same page here. So we're in radians from 0 to pi, we can clearly see that we're going to work with solutions in quadrants 1 and 2 only, okay? So if we, for example, were trying to find arc cosine of -√3/2, again, cosine, we're looking for x values, right? Sine, we're looking for y values. Tangent, we're looking for y/x. So cosine, we're looking for on the unit circle. Where do we see the x value as -√3/2? Technically, it's in two places, right? Here's the x value -√3/2. Some people might do a common mistake and they'll maybe put two answers, 5pi/6 and 7pi/6. But again, we talked about your answers better be between quadrants 1 and 2. And also 7pi/6 is not within the interval between 0 and pi. So the correct answer is going to be 5pi/6. Right? So that is between 0 and pi, right? So just to triple check, 5pi/6 is inside between 0 and pi, because pi can be disguised as 6pi/6, right? We cancel out the 6. So we can see that 5 is between 0 and 6, so it does check out. So if we wanted to, let's try these examples here. So inverse cosine of +√3/2. So again, we're looking at the x values and we're only looking between quadrants 1 and 2. So our answer or solution is going to be pi/6. Okay, so how about arc cosine of 0? So where do we see as the x value is 0? It would be over here, right? So our answer is going to be pi/2. So the thing about arc cosine is really nice is wherever you are looking in quadrants 1 and 2, wherever that radian is, that's the answer. Remember, as opposed to arc sine, if we were looking at a quadrant 4 answer, it would have to be an extra step. You would have to subtract by 2 pi to find that coterminal angle. So with arc cosine, there's no extra step. Once you see the radians between quadrants 1 and 2, you are done. So here's a cool question here. So we're going to show in two different ways why, if we were looking for inverse cosine of 3, right? So in other words, we want to find f of 3. So why is it impossible? So remember, the domain of the inverse function is between -1 and +1, right? So if we are inputting a 3 into the function, already we can see that 3 is not even inside the interval. So that's one reason why, is because 3 is not inside the domain interval, right, between -1 and +1. And the other reason, right, so if this would be reason number 1, then reason number 2 would be, well, let's take a look at if we were to just sketch a right triangle, right? So here's theta. So technically, right, so we're working with the cosine ratio. So let's just look, I know this is well, actually, yeah, let me keep it inverse so I won't confuse anybody. So in general, when we look at inverse, right, we are looking at the angle here, but what is the input? Whoops. In general, it's the ratio. And remember, in SOHCAHTOA, A stands for adjacent and H stands for hypotenuse. So if we look over here, right? So adjacent over hypotenuse In other words, 3, we could write 3 over 1. That means that the adjacent side where theta is 3 and the hypotenuse is 1. So the adjacent side would be here and the hypotenuse would be over here. This is impossible because remember, the hypotenuse length always is the longest side. So we can see the hypotenuse is 1 and 1 is smaller than 3. Can't have that. Last but not least, we're going to see the range for the arctangent function. So just like the other two, we're going to be looking at the horizontal line test. That pretty much messes everything up. But before we talk about that, here are 5 periods of the tangent function. And if we use the horizontal line test, we can clearly see, just like the other ones, it fails the horizontal line test because it hits the graph in more than one spot. But this relation does pass the vertical line test, so the tangent is a function, but the inverse is not a function because it fails the horizontal line test. So just like the other ones, we're going to restrict the domain, and we're going to look for anything that's centered around the origin or positive, right? So we can clearly see within each of the asymptotes that works out, right? So within these asymptotes here, we can see that they all pass both the horizontal and the vertical line tests, right? So again, we want to look for something that centers around the origin so we can see between negative pi over 2 and positive pi over 2. But notice we cannot include those n values because clearly we can see here are the asymptotes, right? There's an asymptote at negative pi over 2 and positive pi over 2. So again, we're going to restrict the domain and we're not going to include the n values because there are asymptotes there. So we can use the parentheses. It's not the bracket. Again, we're not including the n values. So let's take a look at the domain and range of that piece. Right, so again, it's called the arctangent because it's going to look like an arc. So the domain is going to be between negative pi over 2 and positive pi over 2. Again, not including those n values because of those asymptotes. And the range would be all real numbers. So I don't know if you've seen this before. That's all real numbers, or you could just write all real numbers. So we're going to see when we do the inverse, look at the inverse graph, the domain and range will be switching. So here would be the arctangent graph, right? So instead of the asymptotes being vertical at negative pi over 2 and positive pi over 2, now we can see that they're going to be horizontal asymptotes, right? So we're at negative pi over 2 and positive pi over 2. So that's going to be our range. And we can see the domain is going to now be all real numbers, right? So it does, in fact, switch. So if we looked at the arctan, the domain now is going to be all real numbers, right? Or if you, again, have seen this symbol. And the range, now it's going to be between negative pi over 2 and positive pi over 2, not including those values because we have asymptotes there. So whenever you do an arctan problem, your answer better be between negative pi over 2 and positive pi over 2. And so if we use the graph really quickly to find inverse tan or arctan of 0, so if the function, right, was arctangent of x, right, it's now a function, we can see, because now it passes the vertical line test. So we're going to be plugging in 0. So we're finding f of 0, right? So that's inverse tan of 0, which is what we are looking for. And again, in Algebra 2, this is relates to on the graph that when you input 0, in other words, it's your x value, what is the y value? And we can see that when x equals 0, y equals 0. So the final answer here will be 0. And if we look at arctan of 0 on the unit circle, now remember that x is cosine, right? Sine would be the y value of the coordinate. Tangent, we're looking for the y value divided by the x value. So again, if we want to just confirm our answer using the unit circle, tangent is y over x. So what y value divided by x value would give me 0? And we can confirm it would be at 0 radians, because here's my ordered pair. The y value is 0 and the x value is 1. 0 divided by 1 is 0. So that also works out. Now notice technically over here at pi radians, 0 divided by -1 is also 0, but pi cannot be our answers again, because your answer has to be within the restriction. So pi would be too big. And so just like the arcsine, arctangent is similar in that we are looking in quadrants 1 and 4, because again, 3 pi over 2 is the same spot as -pi/2. It's a coterminal angle. The problem is, right, so the only difference is that it's not including pi/2 and -pi/2. And just to do a check, if we look at pi/2, when we do the y value divided by the x value, y is 1 and the x value is 0, it's not 0, like a lot of people love to make that mistakes, but it's undefined. Okay, and that's where a vertical asymptote on the original function would come from. So again, the -pi/2 can't include that, because similarly, if we did the y value divided by the x value, this is also undefined. Okay, so it cannot include the endpoints. It's the only difference between arctan and arcsine. So if we so I talked about, right, it's going to be between quadrants 1 and 4. Okay, so what if we were asked for arctan or inverse tan of 1? So again, in your head, you have to ask yourself, okay, tangent. So when I look at an ordered pair, when I take the y value divided by the x value, do I get a positive 1? So keep in mind, whenever you divide something by itself, you get 1. So the only time where we see matching x and y values are here, right? Square root of 2 over 2 divided by itself gives us 1. So our correct answer would be pi/4, because we are looking within quadrants 1 and 4. Technically speaking, right? So some people might say, oh, 5 pi/4. Because a negative divided by a negative also gives us a positive, okay? That's why it's important to remember the quadrants. You're only looking at quadrants 1 and 4. Okay, so let's try, so that was a quadrant 1 solution. So similarly to the arctangent quadrant 4 scenario, so whenever your solution falls in quadrant 4, again, we have to subtract by 2 pi radians. In other words, find the coterminal angle, because that will always, 100% of the time, ensure that you're going to be within the correct interval. So if you were asked, what is arctangent of -1? So what y value divided by x value would give you a -1 in the unit circle? So we're still looking for the square root 2 over 2's, right? Because anything divided by itself is 1. But now we're going to look over here at 7 pi/4, right? Because a negative divided by a positive, so in this case, that would be -1. And again, a lot of people would write 7 pi/4 as an answer, but that is not correct, because it's not inside the correct range. So again, every time you get a quadrant 4 answers, just like the arcsine, you're going to subtract by 2 pi radians, right? So we need common denominators. So if this is 1, we're going to multiply top and bottom by 4. So we're looking at 7 pi/4 minus 8 pi over 4. So the correct answer would be negative pi over 4. Okay, so last but not least, we're going to be doing something that a lot of people are always confused about. So what if you're asked inverse tan of negative square root of 3 over 3? Ugh. So when you do a y value divided by x value, do you get negative square root of 3 over 3? People usually hate the arctans because it takes a little bit more work. So we already talked about so it's not going to be, right? So if we look at quadrants 1 and 4, it's definitely not going to be the square root of 2 over 2 divided by square root of 2 over 2, right? Because that's going to equal 1. Same thing over here, negative square root of 2 over 2 divided by positive square root of 2 over 2, that would be negative 1. So we are looking at either the scenario where the x value is 1/2 and the y value is square root of 3 over 2, or vice versa. Okay, so on the side, I always tell people you might want to, because I forget too, which one is which. So let's take a look at if you had the x value as 1/2, right? So what happens when you take the y value divided by the x value, right? So this is going to be like a keep change flip. So that's square root of 3 over 2 times the reciprocal. Okay, and the 2's cancel out. So we get square root of 3. But so that's not going to be the one, right? So that's going to be question number 2. That it looks like then our answer for this case, right, is going to be pi over 3. That's our guy. So that was question number 2. So if this produces a square root of 3 when you divide y and x, so that means by process of elimination, right, it's going to have to be a scenario where the x value is square root of 3 over 2. Okay, so it's definitely not going to be pi over 3 because that's where the x value is 1/2. And it's not going to be at the 5 pi over 3 because the x value is still 1/2. So it looks like our process of elimination is going to give us pi over 6 and 11 pi over 6 area. So when we do y divided by x, we can even do a check if we use the y value 1/2 divided by the x value, right? And then we're going to do keep change flip in order to simplify. The 2's cancel, and this is equal to 1 divided by square root of 3. But wait a minute, we want square root of 3 over 3. Turns out that they're the exact same number because if we what's called rationalize the denominator, we don't like radicals in the denominator. So we can really multiply by 1 because anything by itself is 1. But we can disguise the 1 as square root of 3 divided by square root of 3, right? Because anything divided by itself is 1. But why do we do that? Because now when we multiply, 1 times square root of 3 is square root of 3, and square root of 3 times square root of 3 is square root of 9, which is 3. So square root of 3 over 3 is the same exact number as 1 divided by square root of 3. You can fact check me if you enter those values on the calculator. But this is positive square root of 3 over 3. We want negative, right? So it looks like, right, a negative divided by a positive, that is a negative. So again, a very common mistake is people would write 11 pi over 6, but unfortunately that is not in the correct restriction. So we did talk about whenever you get a quadrant 4 answer, to find the coterminal angle that puts you in the correct restriction. So every single time you can subtract by 2 pi and it'll get it done, right? So this is really over 1 and we can multiply top and bottom by 6. So that's 11 pi over 6 minus 12 pi over 6. So that correct answer is going to be negative pi over 6, and that is inside the correct interval. Give this video a thumbs up if you liked the lesson, and In case you were learning this for the first time or your teacher was teaching this for the first time, I'll leave the link in the description below. This is my website where what the lesson that you just saw is pretty much just a snippet and is part of the packet that I created. And among other things, there's homework assignments, there's answer keys. So don't forget to subscribe to my channel to make sure you don't miss out on future videos.